Good day friends. Here we are to learn about the content of Module 4 and Module 5 of OpenStudio software. In previous 3 modules, we have learned about how to create building model, how to add geometry in the building model, and after creating geometry, how to set schedule set, rule set schedules, define space types, construction sets, and finally we also seen that how to have ideal air load added. So all those modules were not inclusive of HVAC system, and in this particular one we will define what is HVAC system with respect to OpenStudio software, and we will also learn different types of HVAC system and zoning thumb rules for HVAC system. So the content of this introduction video as well as modules are like this. It starts with how to add zones and then follow different templates which are readily available in OpenStudio. How to size HVAC system. There are 3 different HVAC system in OpenStudio. So zone equipment, air loop and plant loop. Their selection for equipment on demand side and supply side, as well as their sizing, their temperature control. That is all talked about in this video series, followed by service hot water definition, and lastly there is performance of simulation for same model but now inclusive of HVAC system. So if we elaborate the content of this module, it is like this. It talks about HVAC system for a building. We know that heating, ventilation, air conditioning system not only considers temperature and humidity but also supplies fresh air to meet CO2 requirement, CO2 reduction requirement, and also reduce other contaminants. So associated with HVAC system, one more important concept, that is thermal zoning. OpenStudio divides building into spaces, and these spaces are dividing into surfaces and subsurfaces. Say for example, windows, walls makes surfaces and they makes a room. So this thermal zones are served by HVAC system and they are comprising of one or more spaces. Normally a thermal zone is a bunch of area or space which is served by a single thermostat. So how they are being clubbed, that is discussed in this modules. So here there is a diagram showing 4 rooms or areas, and among them you can see that the upper one, that is one zone, while the other 3 are serving as a second zone. So how this zoning is done, that is discussed. One more diagram is here which shows that on the one side of a corridor or a stair wall there are a bunch of rooms, while other one there are other set of rooms. So how to zone those types of room, that principles are shown over here. Our normal rules which are followed when we are combining spaces are like this. They depends on surface area, operation timings, they depends on their connectivity, their size, the variation in internal loads, and their controllability. So what external boundary conditions they are exposed to, that decides how rooms are zoned. Say for example, some are exposed to south direction while other are exposed to north direction, or some rooms have large number of windows and open spaces, surfaces, doors, while other has a plain wall. So while zoning them, we have to keep them in mind that the rooms with the similar exterior exposure should be having same thermal zone. Otherwise, there will be a difference of temperature in cold and hot days, especially whenever the temperature is extreme. Just like that, what similar boundary conditions they are faced off, as just said that some of the room will be facing east direction, which might have a morning heat load, while some of them will be on the other direction which have evening heat load. So grouping the spaces on east and west facade into a single thermal zone, it may produce less desirable results because they may experience different interior as well as exterior boundary conditions. Then what is the proximity and connectiveness of the space? If the building is connected on the same floor or adjacent floors, then they are equally connected with doors or corridors. So how they are connected, that also decides zoning. Size also matter. When we talk of a large size building, large conference room, or a large size warehouse is there, then we cannot assume them as a single zone, because some surfaces will be having a larger heat load which is exposed to higher sun area, while some surfaces which are away from sun solar radiation, they will have lower heat load. So we have to consider them, and we have to divide them into number of spaces as well as thermal zones. Then their internal load variation is also possible. Say for example, a building is used as a data center where some part of the building has IT servers located, and there will be huge heat load produced, while other rooms are simple office areas or other type of areas. So there again thermal zoning has to be done very precisely. And controllability is also an issue. At times, different temperature controls are required in different offices or hotel rooms. So over there, zoning is done in such a way that individual thermal zone is allocated to individual room. So based on all these principles, zoning is shown in this existing model. Then there is a discussion about different types of HVAC system as per OpenStudio. They are as said zone HVAC, air system, and plant system. So zone HVAC system, they are basically, we can say that it is a family of components which represents a specific pre-confined HVAC system. When we say a package AC unit or kind of rooftop unit, then they are fall into this category. And a common application of this is when we are applying them to hotel room or small residential complexes. All zone HVAC system in OpenStudio include a prescribed arrangement of subcomponents which are fixed. We may not make a major change in those components. So how to have zone equipment added, that is shown over here. Then comes air loop, which is OpenStudio is capable of modeling single and multi-zone air handler using this air loop HVAC model. And here we can drag and drop the equipment related to air loop like fan, heating coil, cooling coil, and other wide variety of equipment. So that is discussed in this air loop system. Compared to zone equipment, air loops and plant loops offer far better configurability. We can make them as per tailor-made requirement, and we can do a lot of customization as per the project requirement. So here there is an image shown for air loop system. So how to select equipment, drag them, size them, how the control temperature set for that. That is a part of this module 4 and module 5. Just like that, plant loop system which handles hot water, cold water, condensate water. So how they are being managed, that is shown over here. All the equipment as well as loops related to them, they are shown over here. Also how to interrelate air loop and plant loop, that is very important part, and that is also part of this video series. So in totality, it talks about entire HVAC plant of a building. And if you are an engineer, constructor, or energy modeler, this course is definitely helpful to you. Thank you for joining.